Hello.
Hello.
So I guess our group dwindled in size.
I guess so.
It's bad for him.
I know.
Okay, I just need to finish sending this one text and then I'm all yours.
Okay.
Okay,
Okay.
so how far did you get?
Like only halfway through the first assignment. It's been a very long week for me.
Okay, so I'm actually done with everything except the group assignments.
Jeez. Look at you.
But so I don't know. How do you want to go about doing this?
So, I did very poorly on the first test.
Yeah.
So, I
End up
think. Hmm.
What did you end up getting?
Let's just not even talk about it.
Hey, all right.
Just real bad, real bad. Um. So, I don't know how to do things differently so that I understand. Because it all seems to make sense when I do it with you guys. I'm like, oh yeah.
Right.
And then I'm like, apparently when I get in to do it by myself, I'm like, oh no.
Well, are you watching the videos?
um, no. Where are the videos?
Okay, so where it says what our assignments are or what the reading assignment is. So here, let's
Like,
go.
where the individual preparation is?
Yes. So then, well, no. Let me go somewhere else here. Hold on. I'm gonna share my screen with you.
Okay.
Okay. So get to share. Okay. So do you see my right for here? It's for my site class, textbook reading. Is that what you're looking at?
I can see your screen. Hold on.
Okay. All right. So let me go to here. Okay. So we'll go to this week's lesson. So
Okay.
when it comes up here, so yeah, so it has the individual preparation. So it says
Mm-hmm.
this. These right here are the links to the videos that explain this. So for me, I'll skim through the reading, but I'll watch these videos. So let me show
Okay.
how it's like what comes up.
Yeah.
And I get way more out of these videos than I
Then
do
just reading it.
reading it. Yeah. So like he really goes through it and shows examples and whatever. So
All
it,
right.
it obviously takes a little bit. I mean, I probably spend more time on statistics than I do any other class, which is why I think it should be a 3 or a 4 credit class rather than a 3. But
Yeah.
I watch all the videos, and then when you do the preparation assignment, then you can watch the videos of then. So how I structure my thing is I skim through the reading, then I watch both of these videos, and I pretty much write down every single thing that each of the slides say and do. And then
Okay.
after that, then I go to the preparation assignment. And instead of doing the preparation assignment on my own, I do it with him. I do it while he's doing it. And then I'll write down any other notes that he teaches it maybe a little bit differently or whatever. So then I do that and then I do the homework assignment. And then I do the homework quiz.
Okay. I will have to watch the videos and do that. That's a good plan.
For me, it just makes it makes
more sense. Yeah. Okay, so are we supposed to go over the assignment?
So yeah, we're supposed to go over the preparation assignment,
Okay.
and we're supposed to do the group and the whole. So okay, so we were supposed to do part 2 together of the preparation assignment, and
Mm-hmm.
go over go over the homework.
Okay, so do you want to do the preparation and then we can do our quizzes?
Yeah,
And keep going on with our life.
yeah. So okay, wait, let me. Okay. Oops.
And I'll start watching those videos before we meet.
So do you want to go over the whole preparation assignment or just the part 2?
Let's just do part 2. Maybe next time. Right now I don't have enough time to do all of that and do our.
Okay. Okay, me either. So at 2:30 I've got to go pick up my son. So
All right.
okay, so for part 1, this has to do with the National Board of Realtors. This guy wants to see if the mean, if most people in his area are 47 years are buying second homes, like that is the national average, and so he wants to compare it to it. Okay, so number 1 on part 2, it says, what are the requirements for creating a 95% confidence t-interval? And the answer to that is SRS and normal distribution.
Okay.
Do you want me just to tell you the answers? Because I don't, like, if I explain, like, if you haven't gone through it, it's gonna not, I don't know what.
Yeah, I don't know. Like, I don't want to get marked down if we don't go through it, but I haven't done that part, so I don't want you to sit here and give me the answers, you know?
Right.
So,
Okay, so what I'll do is I'll go through and give you the formulas and plug in the numbers and then give you the answer. So you probably won't necessarily understand what I'm saying, but at least when you go back and watch the videos, you'll go, oh, okay, I've seen this.
okay.
Is that good?
Mm-hmm.
Okay, so number 2, with the data above, create a 95% confidence interval to estimate the mean age. Okay, so in order to find a t-score, which is something new, you do x bar, and then you do a plus or minus the t-score, and then you times that by the sample standard deviation, which is now S, divided by the square root of the sample. So in this case, it's 46.73 minus 2.1448 times 8.83 divided by the square root of 15.
All right, wait a minute. I think I have the wrong assignment open.
Okay.
So you're in lesson 10, right?
Oh, no, I'm in 11. I'm sorry.
Okay. I was like, wait, what are you
I'm
reading?
an overachiever today. So let's see. Okay, sorry. All right, so so which one are we supposed to go through?
So it says part 2, what are 3 assumptions that need to be checked before you compute a confidence interval for a mean?
What number is that?
6 for part 2.
Oh, okay.
And then it starts talking about the GMAT and what's like the points estimated and create a 95% confidence interval.
Okay. Okay. So numbers. Okay, so what are the 3 assumptions that need to be made? Okay, so that the sample has to be a simple random sample, so SRS.
Mm-hmm.
The distribution is normal, and the standard deviation is known.
And did you find that in the video or in the reading?
What was that? That
I
was
said,
it's in both, but he really explains it more in the videos.
okay.
Okay. So the graduate managed, or so this is the GMAT one. So the sample mean for these 50 students is 541, and so the sample mean is the point estimate for the population mean. So it's 541.
Okay.
So anytime they ask what is the point estimate, it's always the population mean. You know. So number 8, create a 95% confidence interval for the population mean. Okay, so we're still using the Z-score.
Wait, hold on just a second. You said anytime they ask for the population mean.
No, anytime they ask for the point estimate, it's the population mean.
Okay. All right, so it breaks down.
In the question, it's the mean we're told is 541. And so then that's the point estimate.
Okay.
Okay,
Sorry, threw you off there, but.
Hold on. I'm having a little situation right now, so hold on just a second. Okay, so to create a 95% confidence interval, so you do X bar plus or minus the Z-score times the standard deviation over the square root of the sample size. So in this question, when you plug all those numbers in, it's 541 minus 1.96 times 32 over the square root of 50. And that gives us a lower bound of 532.13.
Okay.
And then the upper bound, you just opposite it. So 541 plus 1.96 times 32 divided by square root of 50. And that gives us the upper bound of 549.87. And then the way you would write that answer is we're 95% confident that the true mean of the whole population is between 532.13 and 549.87.
Okay. So how does the margin of error for the 95% confidence interval? So you're looking at, that was for 9, right?
That was for number 8.
Oh.
So number 9 says, say that the sample mean changes to n equals 100. Now compute a 95% confidence interval. Okay, well, all you do is change that bottom number, the square root of 50 in number 8 to the square root of 100 in number 9. And then your answer is 543 and 547.
Okay.
All right, so number 10, how does the margin of error for the 95% confidence interval of the same sample size 50 compare to the margin of error? Okay, so now we just have to look at both of those. Okay, so the answer is the larger the sample size, the smaller the interval.
Okay.
Okay, and then number 11, create a 90% confidence interval for the original participants. Okay, so now in this case, now all of the numbers stay the same, except the 1.96 is now 1.65.
How do you know that?
That's in the book and in the videos, but the 95% confidence interval, or the 95% is 1.96, 90 is always 1.65, and 99 something else. I don't remember what it is off the top of my head, but it's in my notes.
That's okay.
Okay. But it gives you a little box that tells you what it always is.
Mm-hmm.
Okay, so number 12, how does the margin of error for the 95 confidence interval and the 90% confidence interval? So now basically we're just comparing those two answers again. And so it says as our margin of error gets smaller, our range of intervals gets smaller.
Margin of error gets smaller when the range gets smaller. Okay. Okay.
All right, so number 13. The BYU Idaho professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will be needed in the sample for a 95% confidence? Okay, so in order to do this, the formula is n equals z times 0 over m, and then you square all of it. So it's n equals 1.96 times 32. The 1.96 times 32 is over 5, and then you square it. And so then the answer is, you'll come up with 1.573. But since we're looking to see how many people we need in a sample, we always have to round up because we need to include the 0.3 in that sample size. So you need to go to 158.
Great.
Great. Okay. Now we move on.
All right. So should we do our test thing?
Yeah. So start here. Yeah. Okay, so find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25. Okay, hold on. Let me get this piece of paper.
Do you want to screen share with me so I can understand how you're doing all of this?
Well,
Or-
I won't be doing it. I'll be doing it on paper probably. I can't.
Oh.
But I can still.
Well, let me grab some paper and see if I can follow along with you. Hold on just a second, okay?
Okay.
Okay.
Okay, so it says so we're doing an error of a 90%. So we're going to use the number 1.645. Okay, so in big parentheses, you'll write 1.645 times the standard deviation. Yes, the standard deviation, which is 50,
So times
over
the
the square root of the sample size, which is 25. And so plug that into the calculator. 1.645 times 50 divided, okay, just a second. Okay, we don't need the parentheses. Okay, so 1.645 times 50 divided by the square root of 20. And that equals 16.45. 16. How is that right? 1.645 times 50 divided by the square root. Oh, it is right. Okay. All right, 16.45. Okay. Which of the following statements is true? U is point estimator. O is variable estimator. X is point estimator. Well, when they write it funny, let's see. The statistic X estimates. Okay, so the sample mean estimates the population. So X, I think it's this one. X is a point estimator of U.
Why do you think it's that one?
Because
I'm not saying I don't disagree with you. I'm just saying.
Because the point estimator it is always the sample mean. And so, when you are at the beginning of the video, it goes through the definitions of parameters and statistics. One of the definitions is the sample mean estimates the population mean. So to me, this is the sample mean right here. It's a point estimator of the population mean. That's why I think that.
Okay.
It was either between this one or this one, but the way I read it, I think it's this one.
Okay.
Okay, so Tina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation and 15. She collects a simple random sample, K. Computes, K. Use what is the lower limit of this confidence interval? Okay, so this is okay, so you take the mean. Did they give that? Yes, 5. And the first time we're gonna subtract it, and okay, and we're gonna times 1.96 times the standard deviation, which is 50, over the square root of the sample size, which is 25, and that equals minus times that's 36. So that's the lower limit is 36. So then the upper limit, you do the opposite. You do 5, 26 plus, parentheses, 1.96 times 50 divided by the square root of 25 equals, how in the world? Maybe this is 5.6. Hold on. 5.6. Okay. Okay. One sec. Let me try this. 3 I must have done it wrong. Like entered it into the calculator. The square root minus 1. Okay, sorry. Okay, so that bottom limit is, sorry, is 5.064, and the upper limit is 545.6.
Okay.
Okay, so what would happen to the width of the confidence interval if Gina increased the sample size? So, just for explaining. The larger the sample size, the smaller the interval. So what would happen to the width of the confidence interval?
It would decrease. Didn't you just say that's right?
Yep, that's right. What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? It would increase. So if you increase the confidence level, you also increase the interval.
Yeah.
Double check though to make sure. Yes, that's right. Okay, Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know that the standard deviation is 0 is 1. They want 95 hours. Okay, so what size sample do they need? So that is n equals, okay, and we are gonna, what is it? What are we doing? 90 or 95? Does it say? You know, this time we want a 95% confidence. Okay, so that's 1.96 times the standard deviation, which is 50, divided by the level of confidence. So, with a margin of error of 50 hours. Okay, I'm sorry, the standard deviation is 400. Okay, so it's n equals 1.96 times 400 divided by 50. Okay, and then plug that all in. One point nine six times 400. Oh wait, and then you square it. So I need to add parentheses. Okay, so parentheses 1.96 times 400 divided by 50 parentheses square equals, they need a sample size of 245.8 that you have to round it up, so 246.
Okay.
Okay. The mean salary of actuaries is 100,000 and the standard deviation is 36. You're interested to know if the mean salary for women or lower, you set up a hypothesis for this test with a level of significance of 0.05. Okay, you select a simple random sample of 36. You find that the mean, okay. What is the lower and middle of this thing? Okay. So, let's see. The mean. Oh. Okay, so you're gonna do 1.6 times. Hold on, I don't know how to read this here. With the mean. Okay, so we're gonna do 111,000. Are we finding minus 1.86 times standard deviation? 6,730 divided by the square root of the sample mean, which is 36. And get equals. So it's 99,001. Okay, so
99,001.
And the upper limit is 100,000 plus parentheses 6 times 36 divided by 36 equals 122. Okay. Okay, there are 3 requirements that need to be checked when computing a confidence interval for they are sample, the normal distribution, and population. Okay, so it's all 50.
Okay.
Submit. Submit.
Okay.
Ah! Alright, I don't know what I did wrong on those two. Sorry.
You know what? I'm always surprised when I get any of them right.
Okay, I'm gonna have to go back and look at that one. So, alright, done. Alright, and then for less than 11, all that I know I have time to do the thing, but I can go pick him up and get back on.
Um,
To do.
yeah, that's fine. I just can work. I got so much other stuff I need to do too.
Okay.
How long? Well, actually, let me ask you. How long does it usually take you?
To get him?
Yeah.
5 minutes. He's like literally just a few houses down the street.
Oh, okay.
So, I mean, I have to drive there. I mean, it's not on the same street, but it'll
No,
just take me a
no.
second.
I just was making sure it wasn't like a, you had to drive to, 45 minutes away and come back.
Oh no, he's just at a friend's house. So okay, I can probably go through the preparation assignment though. We can do part 2 real quick.
Okay, let me open it.
I'm gonna open mine. Okay, do you have yours open yet?
Yeah.
Okay, so we'll do part 2. Number 1, I started with before. So this is the one I was telling you about. The realtor wants to.
Okay.
So this is the number 1. It's SSRS normal distribution.
Okay.
Okay.
This is the one that you were telling me about that T interval thing, right?
Yes. Okay, so now we're going to do T-scores and T-intervals and all that. So it's kind of the same thing as what we did in the previous chapter or lesson, but we're just adding another step. And this is all done in SPSS too. So I'll just give you the formulas and all that again. Okay, so with the data above, create a 95% confidence interval. Okay, so now the formula has changed a little bit. So we're going to do 46.73 minus 2.1448 times 8.83 over the square root of 15. And the numbers that you'll get from the SPSS is that T-score. That comes from calculation that you do in SPSS. So anyhow, you do that, and then you do the opposite 46.73 plus 2.1448, blah, 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 and your two answers are 41.8 and 51.6. Okay, somebody just rang my doorbell. What if somebody brought my kid home tapped out? Hey, can you do me a favor real quick? Is there any way you can look at that? Do you remember? Yeah. If you go out on this street and then turn left, go over the train tracks, turn right. Turn left and come off right there on the right. I'm doing my statistics meeting. Yay, my mom showed up right at the perfect time and she's gonna go pick him up. So. Okay.
You just have
what?
One, right?
What was that?
You just have one son, right?
No, I have 3.
Oh.
But my one is in kindergarten and it's only half day. So the other ones don't get home till 3:30. So.
I don't know where I thought you only had one, but
Because he's the one that's always here when we're meeting, but
maybe that's why.
All right, so number 3, now create a 99% confidence interval. Okay, so it's all of the same numbers again, except you change that 2.1448 to 2.9768. And then you get, you do the subtraction and the addition, and you get 39.9 and 53.5.
Okay.
Okay, and then the next one is using the SPS. You've got to calculate these. So there's no formula or anything. You just do it, and the answer comes out to 41.845 and 51.622.
Okay.
And B is 39.949 and 53.518. You know what? I can show you how to do it, though. Do you want me to open up SPSS and
Sure, yeah.
show you that?
That would probably be good.
Okay, let me think. Here, open. Because I'll have to open, I don't remember which. You see them. Okay, so it's just using come on, open. What is going on? Sorry. Here. Oh, it's just taking forever to open. Sorry. We can keep going and I'll go back to it.
Okay.
Okay, so how does the margin of error of the 95% confidence interval compare to the 90? So the bigger the percentage, the wider the range, or the higher the confidence, the wider the interval.
That's like that one before, right?
Yeah. Okay, so can you see that I have SPSS pulled up?
No, I can just see you.
Okay, hold on just a second. Let me screen share. Okay, can you see it now?
Nope. Still just see you.
Oh. All right, let's try this again. Screen share. Start.
There you go.
Okay. All right.
All right.
So what did
Can I
Jasper
pause
do?
you for 1 second?
Yeah.
I'm gonna run to the bathroom super quick, okay?
Okay. Sounds good.
So did you just type those in, or?
Yeah, I just typed them in.
Okay.
So these are those from part 2, the realtor dude. So those are those numbers that are listed.
Uh-huh.
You see on that first one. Okay, so 47, 35, 3, blah, blah, blah. Okay, so
Yeah.
I just entered all of them in, and then you're going to come up to here to analyze, and then you'll go to descriptive statistics, oops, explore, and then you need to move this over to the dependent list, hit statistics, and see where it says right here the confidence interval for the mean. So this is where, so right now it's set at 95. So when you hit continue,
Wait.
oh,
I don't see where you say 95. Are you looking back at the sheet? Because when you hit dependent list, it just goes back to your SSPS thing. Like, I don't see if you're seeing anything else.
Okay, so I moved this to the dependent list.
Yeah.
And then I hit statistics right here.
Uh-huh.
And then the 95% comes from question 4, number A.
Oh, okay.
We're looking for the 95% confidence interval. So that's how come I know we're looking for 95. And so then I hit continue. And then okay. Okay, and then we'll say right here, the 95% confidence interval, the lower bound is 41.8449. Upper bound is 5.162. Okay. So then when you want to do it for 99, you do the same thing, except you change this to 99. Oh,
I don't think you can see everything you're doing.
you cannot?
No, because you just said change this to 99, and I don't see where you're changing anything.
What do you see?
Can you see what I'm seeing?
I just see your picture.
Screen share. Oh no. Anything?
No.
Well, maybe we can't both screen. All I can see is your SSPS thing. The screen just, it looks like it did when you originally just put all the numbers in.
Okay, well then I guess it's not going to let me show you the how to do it.
Okay.
Sorry.
It's okay.
No. Okay, let's see. All right. I'm going to stop right now. Okay. All right. So we did number 5. So number 6 is rather than estimating the age of his clients, the realtor would like to test the claim that his clients are different. So then we're going to do a null hypothesis. So A, state the null and the alternative hypothesis. The null is U equals 47. And the alternative is U does not equal 47. Okay, and then you compute the test statistic, and you have to do that in SPSS, but you can also do it by hand. So it says to do it by hand first. And so that formula, when you plug in all the numbers, is T equals 46.73 minus 47 over 8.83 divided by the square root of 15. And then
By the square
that
root
all
of
equals,
15.
sorry, what?
I just said by the square root of 15. I was writing down what you were saying.
Oh, okay.
I
And
just
then
talked
that
out loud.
answer is t equals negative 0.118. And then C, state the degrees of freedom. That comes from SPSS. That's 14. And then sketch the t distribution and shape the area which represents so you make one of those, what it looks like in the applet. So it's got an arch. And then you're gonna shade both sides of the arch, and you'll leave the middle open.
Okay.
And then in order to use the software to compute the p-value, that comes out to 0.909. And then F, state your decision. Do you reject the null hypothesis or fail to reject at the 0.5 level of significance? So the 0.90, which is our p-value, is greater than 0.05. So we fail to reject the null. And then G, present your conclusion, is we have insufficient evidence to say that the mean age of second home buyers is different than the national average of 47. Okay. Okay, so should we try and do this, Quizola?
Sure.
What's that? My dog's looking around.
What's happening? Scotty.
Okay, so start.
In previous lessons, we assumed the population standard deviation was O was known. In this lesson, we are making a different assumption about O. What has changed?
Okay. That the standard deviation is unknown. Okay, so the null hypothesis is 8. The alternative is greater than 8. The population is not known. Becca collects a size sample of 9. That her sample mean is 11, and her sample standard deviation is 6. Use this information. Blah blah blah. Is O known?
So no, because it just said it's unknown. Okay.
So
I like this like that.
right. Yeah, that's easy enough, right? Okay. So then what is the value of t? Do they want us to figure that out in SPSS? I don't know if we can because we don't. So we'll have to figure it out by hand, which is fine. I just need to find the formula. Okay. So it's t okay, it's t equals x bar minus that over s equals n. Okay. So t equals 11 minus 8 over the sample deviation, which is 6, over the sample size, which is the square root of 9, equals, okay, let me, I should be able to do this in my head, but I'm not that smart, so.
It's like I would never able to do this in my head.
Sorry, parentheses. 8 parentheses divided by 6. 1.5.
Mom, does that not bring this and it senses metal?
Yes.
You won't get struck.
Okay. Yeah, but if it starts getting lightning and thunder gets closer, then I want you to come in the house, okay? But just a little bit of thunder is okay. You can go outside. She's gonna be fine. You're fine. The square root of 9 is what? 3?
Yeah. I think so. Now you've got myself.
Shut the door, that's fine. Sorry. I'm just checking my math here, sorry.
Yeah, the square root of 9 is 3.
So I don't see how I got that. Okay. 11. Gotta be 11 divided. Sorry, when I have to do parentheses and all of that, that's where I get, like, sometimes I make math errors with my calculator.
I make bad errors all the time. That's why math is not my strong suit.
See, when I do it in the calculator, it's 1.5. But if I did it by hand, okay, so do you have a piece of paper and a pencil?
Yep.
Okay, so t equals 11 minus 8.
Hold on. Okay. T equals 11 minus 8.
Okay, and 11 minus 8 is over 6. And 6 is over the square root of 9.
Yeah.
So 11 minus 8 is 3 over so 6 over the square root of 3. So 6 divided by 3 equals 2. So it should be 3 over 2, right? Which when you calculate that out is 0.33. Is that how you would figure it out in normal life? Or am I wrong?
No, it seems right. Why are you
Because when you do it in the calculator, you don't get that same answer. Let me try something else. 6 divided by the square root of 2 over you get 1.5. So which do I go with? Let me just make sure I've got everything. Okay, 11 is minus 8, which is the hypothesis, over 6, which is the standard deviation, over the square root of 9. Okay. You know what? Let me look at this example and see how I did it in the calculator with it. And then
Okay.
Minus 6 over 0, 7, 3, 8, divided by negative 9. Okay, so I got this answer. divided by parentheses 6 divided by 1.5. All right. I'm going to go with the calculator. Are you okay with that?
I would go with a calculator too.
Okay. So use the following values, which were pulled from the blah, blah, blah. Copy and paste them into the software you're assigned to use using the null hypothesis. Okay. Level of significance. Okay, so hold on a second. Let's get all this entered into SPS. Okay. So the first question is, what is the mean? Okay, so you go, when you're, after you put all of these things into SPSS, you go to Analyze. I think it's Compare Means. No, not yet. Score. Turn it over. Hit OK. And our mean is 98.220. Per sample.
So it's 98.22.
Yeah. Okay, so what is the standard deviation? The sample standard deviation is 0.922. Okay, and now what is the t-score? So we go to Analyze. Or no, cancel. Analyze. Compare means. One sample will be test. Go over to test variables. Okay, our test to 98.6. Come on. 98. Okay. And we are looking for what? T-score is negative 1.843. Okay, what is your p-value? Zero 0.04. And what is the correct decision based on this evidence? Well, level of significance. So 0.04 is less than 0.5.
Yeah.
So we are going to
Reject it.
Okay. Let's do these now. Control copy. Get rid of this. Sorry. Come on. Don't let me copy and paste. Here we go. All right. The first thing we're looking for is the p-value. The test value is what? 40? Yes. Okay. And it's asking for what? Our p-value? Wait, negative. Okay, the p-value is 0.4. What do you do? Well, it's greater than this, so we
So
don't.
you fail to reject them.
You decide to try another alternative hypothesis. This time you use one, you keep the same one, or did the p-value didn't do anything? The p-value doesn't change.
Well, it must do something because we don't have an option to have it not change.
You want to first off, your first alternative hypothesis is different. What is the p-value? Okay, the p-value is found. You don't put any of the level of significance in. All right, hold on. Okay.
It's the bar, well, out there in the,
Okay.
but we need more bars, so we'll check over.
Okay. Thank you. Sorry, I'd help, but I'm in the middle of this, so it's sorry. Okay, thank you. Bye. Maybe I did the thing wrong on the computer. Your first. The same level of significance. Okay, so let me explain that. Like, okay, so the p-value comes from a calculation that you make in SPS test. Oh, you know what? Okay, when you're looking to see if it's just different, it's called a two-tailed thing. I'm sorry, it did change because now that we're looking at a greater than or less than, then it becomes one-tailed, and you take that p-value and you divide it by 2. So you decide to try another blah, blah, blah. You keep the same level of significance. Did the p-value increase or decrease? It decreases, but not enough to it. This is wrong. Okay, so number 11 is actually 0.995.
Okay.
And now that so when you divide this, the 0.995 by 2, which is what you would do for the number 13, then it becomes 0.4975, and that's still greater than 0.01. So you still will reject.
Okay.
So we're still going to fail to reject. So then compare the width of the confidence interval for question 11 to the confidence interval for question 13. Which one of them is wider? Well, the confidence interval should be the same. But let me think this through. Okay, when you put in the p-value, sorry, I'm having a time. How the p-value has anything to do with the interval. I think they're the same. Are you okay if we just guess on one?
Yep.
All right.
Submit.
Yay!
Good.
Hot dog.
Woohoo!
Okay. All right. So I'll get this loaded up and we're done for the week. Woohoo!
Sweet. Gotta do my homework now, and it will be good.
Okay.
Watch those videos.
Okay. All right. Well, yeah, I guess that's it. So I'll just text you next week and we'll figure out a time next week.
Sounds good to me.
Okay. We'll talk to you later.
Bye.